Hello, my name is Nobel Baliza. We are going to start this session on sustainable management and water supply and sewage systems in Nepal. So sorry, the session started a little bit later than expected. So we are going to get started directly with the first presentation. I think it's good if every presenter, before you start your presentation, just give a short introduction about yourself. So my name is Nobel Baliza. I work as a researcher in the International Center for Urban Water Hydroinformatics R&D in Incheon. And I'm going to present shortly an introduction about smart water grid application to Nepal. Yeah, so the summary of the presentation is the following. We are going to start with some introduction and concepts. So we know that 21st century brought new challenges. That's a consequence principally of population growth and global warming. So in the case of less economically developed countries, they are facing serious threat of water scarcity, and that's due to a lot of factors. So it can be aging infrastructure, ICT gap, lack of investment, institutional constraints, poor data, and also the combination of all of these. So the definition of smart water management, which is a new paradigm for the management of water, urban water, especially from IWRA and K-water, is the use of ICT, so information and communication technologies, to provide real-time automated data for use in resolving water challenges to integrated water resource management. So the smart water grid is the case structure for this application of SWM as an architecture which combines sensors, monitors, GIS, satellite mapping, and other data sharing tools. So we have 5 main modules under the smart water grid umbrella. So we've got a real-time water balance assessment module, advanced metering infrastructure, smart metering, which can be leakage detection and WDS management, integrated water distribution system, and water quality improvement. So in the case of Korea, we have 2 main systems of the multi-regional systems, which are managed by K-Water, which is the national corporation of water in Korea, and they ensure approximately 50% of the total water supply. And then we've got the local systems, which are more or less 161 local governments, and they are in charge for 50% of the remaining water supply. So in the case of the Seoul metropolitan area waterworks, it's a very, very big network, as you can say. So as you can see, water supply to 28 local governments, which represents approximately 10 million customers. So the capacity of the network is of approximately 8.5 million cubic meters per day. So that's huge. That represents 50% of the total supply ensured by K-Water, and also 25% of the total water supply in Korea only for this region. So the 2 main work scopes of the network is water supply control and water quality monitoring, and you've got 6 modules to ensure this: real-time network monitoring, demand forecasting, pump scheduling and control, network modeling and analysis, GIS-based facility management, and alarm and leak detection. So in the case of this network, as I said, it's a very big network. It's more than 1,000 kilometers of pipeline. But among these 1,000 kilometers of pipeline, only approximately 200 kilometers are single water pipelines. So that means more of 80% of the supply is ensured through dual pipes. So why is this important? It's because if one pipe has a problem and there is a pipe failure, then we always have another supply route to ensure that there is no discontinuity in water supply, even if there is a pipe breaking. So this is the 8-step process in case of leak. So first, the leak is detected through sensors which send signals in real time. Then an emergency team is organized. A hydraulic analysis of the model is performed because the model is represented into hydraulic modeling software in real time. a linked supply is put together. So that's, as you can see, there is always more than one route to provide water. So if one pipe has a problem and is in a situation of failure, then you can provide water through another pipe. Then they deploy, place a field command vehicle, repair the break, and we go back to ordinary supply. In the case of the automated metering, we've got 3 data transmission technologies. So for short range, it's a wired data transmission technology. It's between the water meters which are in the houses and the remote metering unit, which is collecting at the level of a building the data. Then we've got the mid-range wireless communication system between this RMU and the data concentration unit, which is a logger, which is basically at the scale of a big building or a small neighborhood. And then we've got the long-range wireless network, which is between this base station and the remote monitoring system, which is the centralized system for at the scale of a big city like Seoul or Incheon, for instance. So smart metering deployment in Korea, there is an experience of this in quite a lot of areas. So if we can describe it in 6 steps, it's quite simple. First of all, there is a site survey where the old meters, the traditional meters, which need to be read manually, are replaced by smart meters and display units. A coordinator is installed, so the coordinator is in charge of collecting the data from all the meters deployed on field. Then there is the commissioning step. So the commissioning step is the most important step. It's the step when you ensure that every meter is connected to the coordinator, basically, and that you don't have data lost, meters which are outside of they've fallen outside of the network, and cases like that. So then you process the data acquisition, and you've got a graphical user interface to display the data. So what does it look like? It looks like that. Basically, there is a map. On the visualization map, you can see where your meters are deployed. You can see the number of connected households, the water consumption graph in real time, the cumulative water usage, and also this very important feature here, which is the smart meter status. So the smart meters in green, they are connected to the network and they are working normally. The smart meters in orange, they are connected to the network, but they are not working normally for a certain reason. And the smart meters in red, they are disconnected from the network. So that allows to know where in real time how the situation is going on. So the city of Beni in Nepal is located in the Myagdi district. It's a headquarters of the Myagdi district. It has a population of approximately 33,000 people. As you can see on the picture, it's located at the confluence of 2 rivers, the Kaligandaki and the Myagdi River. And it's as Nepal is a mountainous country, it's located at an average altitude of 900 meters with quite mountainous terrain surrounding the town. So in terms of a few features, the average family size is of approximately 4 people per household. The population growth rate is sustained at more than 3.5%. We've got more or less 24 hours of water supply in summer, but in the case of winter, we've got only 12 hours of supply, and then the rest of the day there is no water supply. So also, because the population rate is always growing, we expect the projected demand in 2020 to be greater than the existing demand. So there is a need for solution to improve the water supply in Beni. The scheme which is currently being used is a gravity scheme. So the gravity scheme, it works under the principle that the source is located higher than the distribution area. So you don't need pumps, you don't need valves, you just need to let the water flow with the gravity basically from the high point to a low point. So there are 2 main systems, the Ritenkarka system, which is really the main source, almost 30 liters per second supply, the Koprekola and Dudekola, which are secondary sources, and then the Pumdikola, which was the 3rd source, but it has been abandoned due to high turbidity in wet season, which makes the water improper to use. So this is the view of the model in the EPA SWIM hydraulic modeling software. So you can distinguish 3 main areas, which are the Beni Bazar, the Beni campus area, and the Mangalgat area. So some figures also about the non-revenue waters for Nepal. So what is non-revenue water is basically between the point when the water enters the network and the point when the water leaves the network, it's the percentage of water which doesn't bring any money to the utility provider. So this is mainly due, in the case of Nepal, it's mainly due to the high non-revenue water figures are mainly due to physical losses, so leakage of the pipes. So you can see that here it's been broken down by seasons, by month, but you can see that in some cases we've got more than 40% of non-revenue water. So that means more than 40% of the water is lost through the process, basically, and doesn't bring any money to the utility. And some studies have also shown that here the unit is Nepalese rupee, and you see that in the case of application of smart water grid technology to Beni, we could save as much as 12 million Nepalese rupee as a benefit of the implementation of this technology. So when you go on field in Beni, what do you find? So you find, as we said, mountainous terrain, so steep slopes, and also a lot of above ground pipelines. So what's the problem with above ground pipelines? They are not buried pipelines. So basically in mountainous terrain like this, if you have landslides, if you have rocks and boulders falling from the slopes, you have a high risk for the pipes to break down. And also we have unprotected pipe junctions. So the junctions are the points in the pipe network which are the most vulnerable to leakage and break. But we don't have a particular protection at these junctions in the terrain. So the consequence, what is it? Well, damaged pipes, as you can see on this picture here, leakage, pipe burst, and this ultimately leads to discontinuous water supply and water quality issues as well. And the same thing is a lack of automation, so which can be observed. So the lack of automation, in the case of the meters, they are manual meters which are read on the field and quite old infrastructure, as you can see. And for the water quality control, it's the same thing. It's all done manually, and it's not done very often. The frequency is not very high. So what's the problem of this lack of automation? And this low data collection frequency? First of all, from the viewpoint of metering, it's difficult to understand the water demand and the water usage patterns because you don't collect enough data at a high frequency. And then the problem in terms of water quality is you don't have a continuous monitoring of water quality. So if you check the water quality maybe once a day, you can have pollutants getting into your network and you won't be able to know it for several hours or maybe for an entire day because you don't have high frequency of data. So this can cause quite a big problem in terms of hazard to population. So we imagined 3 big stages of improvement of the water supply system in Beni. So the first stage is focusing on the water intake, the improvement of the supply pipeline and monitoring of the supply pipeline. The second stage is focusing on the water treatment, and the third stage is focusing on the improvement of the water provision facilities. So we identified a few technologies from Korea which could be applied on field. So from the viewpoint of water treatment, we've got this mobile water treatment unit. So this has been developed in Korea as part of the Smart Water Grid research project. So what it allows is that it has these blocks, basically, these block units for treatment. So some of them are reverse osmosis, some of them are chemical. There is ozonation, there are quite a lot of processes. And you can combine them basically in the order you want. And this allows you to virtually use any input water, so that could be surface water, groundwater, rainwater, treated wastewater, brackish water, even seawater. And you could get a water which matches the purposes and the standards that you want by combining some of these block unit treatment technologies. So that's a very flexible system basically that you could use. It's customized combination process. Then the water shortage assessment tool, this was developed and applied to the Daejongdo Island in Korea. So it's mainly aimed at regions which are quite susceptible to have drought episodes. So it provides a real-time estimation of the water demand and the available water resources to anticipate any possible shortage, basically. So it relies on remote data collection, database management, and forecasting algorithms. Regarding the pipes, so we mentioned the problem of the pipes. Of course, the solution would be to take the sections of pipes which are located above ground and try and bury them. But even with buried pipes, you can have problems of leakage. So this is a solution which also exists in Korea, which is called the 3-step maintenance solution. So it involves a smart prevention sheet. So the smart prevention sheet, you can see it here. Basically, it's put on the pipe. And if there is leakage, it avoids substances from the soil to get into the pipe if there is a leakage. And also at the junctions, you have reinforced junctions with sensors which are sending a signal as soon as a leakage happens. For the smart metering unit, you have smart meters which have been developed in Korea as well. So these ones we are showing here, they are equipped with lithium batteries, so quite long lifetime. They are using the low pole wide area communication protocol. They have an operating range which is quite wide in terms of temperature, and they send 1 meter reading per hour, so that makes 24 meter readings per day, which is quite good granularity of data. And yeah, we also have other options in terms of powering, which is not only lithium batteries, but also solar or water-powered metering devices, which could be used case by case. Now, in the case of Beni and in the case of Nepal, we've got this. In the case of Beni, we've got this average yearly rainfall input, which is 1,600 millimeters per year. Now, that's quite a lot of rainfall. But the problem is, and it's been accentuated by the effects of climate change, as you can see, the distribution of the rainfall throughout the year is not constant. Most of the rainfall, actually almost 80% of the rainfall, it falls from June to September during the wet season, and then during the dry season, you have almost no rainfall input. So we could be using some rainwater harvesting systems like it's been developed here in Lalitpur. So this one is quite a simple system, but you have a lot of systems which can be used for rainwater harvesting. This is just from the roof, basically connecting the roof runoff to a tank, a PVC tank, and then getting your water stored that way. So by doing a very simple calculation, and that's just an example really, but you've got your average annual rainfall, which is that much, as we mentioned earlier. And if you assume that your water demand for a household of 4 people is of approximately 300 liters per day, so 75 liters per day per people, then even applying this to very small areas in Beni, you could still have a few households which would be provisioned by this rainwater harvesting technology. So that's an option which also needs to be investigated, basically. So what are the expected benefits of this smart water grid application to Nepal? So first of all is improvement of water supply system, then improvement of water treatment, real-time monitoring, and having some water assessment tool to give you like a real-time view of the available resources and the water demand. Yeah, so as a conclusion, we can say that smart water management can help achieve efficient use of water resources and resilience of the water system. South Korea has an extensive experience of design, application, and operation of these smart water grids across its territory. Nepal now is facing more and more challenging issues due to population increase, lack of infrastructure, geographical conditions, and the impact of climate change. So the application of these various smart water grid technologies should be investigated at a test-bed scale for wider implementation. Yeah, and that's it for the presentation. Thank you. Yes, so that was the first presentation to launch this session. Now I would like to call Mr. Shrestha from the mayor of Dhulikhel municipality, and he could deliver the presentation about drinking water management in Dhulikhel municipality. So if you are online, please could you share your presentation with us?
Greetings to everyone. This is actually Mr. Ashok Kumar Bendra Shrestha. The mayor is not currently available at Dhulikhel, so I'm Engineer Rajan Neupane from the municipality, and I'm going to present on drinking water management in municipality. First of all, it's my pleasure and I'd like to say thank you to the organizer of the Smart Water Grid International Conference for inviting us and providing us time to speak in such a valuable conference. So I'd like to start from what Dhulikhel is. It is a small hill town located in Kathmandu district, in eastern region of Kathmandu Valley. And it is only 80 kilometers southeast from the capital city. And the municipality is committed to facilitate its people with safe and adequate amount of drinking water with one house, one tap. It is in the 5-year target of the municipality to provide safe and drinkable water in each household within 5 years. And with that commitment, the municipality started its first work in 2017-18 by firstly mapping the available resource and mapping the people who need water.
Excuse me, Mayor, could you share your display? We cannot see your display now. Could you share in your computer?
Yeah, okay, sir.
Thank you.
On the software, if you go on the left, you've got the second icon, which looks like a screen. And if you click there, you can share your screen with us, maybe.
Yeah, it's been done.
There is a bar on the left and the second icon, which looks like a screen. This allows you to share your screen, I think. Because right now we cannot see your screen, so we cannot see your presentation, basically. Yes. Yes, we can see your screen now.
Yeah, thank you.
Thank you.
Actually, the mayor is not currently available, so I'm here from the municipality.
Yeah, please go ahead with the presentation.
Yeah, okay. Like, currently, the city area of Dhulikhel municipality, like the municipality is divided into two parts, like the main city area and into some village areas are also there in municipality. So the main city area is getting drinking water from Dhulikhel water supply and sanitation committee. Actually, the municipality is providing water via community where the people, the consumers, they are directly involved in getting water, and they manage the water committee, and then the water is provided to them. And now it will be connected to Cabre Valley integrated water supply system, where the nearby two municipalities, including Dhulikhel municipality, will be facilitated with drinking water. So the process of systematic water supply and distribution started from the year 2007 through BS, which is 1780, where municipalities started to identify and map available water sources within the territory. The water supply system here in Dhulikhel is decentralized type of system, where the people will get water from their nearby source. And 4,000 households were studied during that period, where 28 different projects will facilitate the 4,000 households, and around 20,000 people will be facilitated with such projects. And the municipality aims to complete such projects in 2020. The major source of water the natural streams, small and big streams, up to 1 liter per second discharge, and 80% of the people will be facilitated with water by gravity flow, whereas 20% will get water through pump distribution. And in case there are some households where the natural stream water is not available, so 8 deep well from groundwater were constructed during this 3 years period, and water supply is being done. Besides, work has been done for rainwater harvesting, recharging groundwater in collaboration with CIAS. And similarly, water summit was held in Dhulikhel in collaboration with WWF and Kathmandu University, where water resource mapping and forest mapping was done in one major river basin for study of sustainability of water resources. So for efficient management of water supply system, Municipality has formulated act where people will get water, which is a single source or multiple source of water and lies in the same geographical territory and include 50 to 500 households. Those will be different 28 schemes. And each scheme will have water supply and sanitation management user committee, where the committee will be liable to management of the system. And from such project, the household will pay the bill of water consumption to the user committee, and they will manage it by themselves. Besides, our municipality is looking a way for collaborating water supply system with information technology, so that sufficient amount of drinking water is supplied to the people of municipality in a scientific and cost-effective way. The major problem is that the current design of system lacks sufficient use of information technology and efficient running of the system. So the municipality is sharing its condition of water supply system technology in the value forum, and I hope we can also learn from other participants as well. Lately, we are all in a crucial situation, so stay safe and healthy. Thank you so much. Thank you, sir. That's all from the
Thank you very much for your very comprehensive presentation. I would like to ask if anybody online has questions maybe about this presentation. If not, then I would have a question about your presentation. You mentioned at some point in the presentation that in the Dulikhel municipality, you've been doing some work for rainwater harvesting and groundwater recharge.
Yes, sir.
So I would like to know maybe a little bit more about this. What have you been implementing for rainwater harvesting and groundwater recharge?
Pardon, please. Sorry, sir, I didn't get you. Can you ask the question one more, please?
Sorry?
I didn't get your question. Can you ask one more?
At one point in your presentation, I think it's at the end of the first page, you said there has been some work about rainwater harvesting and groundwater recharge, and I wanted to know maybe a little bit more about what technologies did you implement or what projects do you have ongoing?
Yeah. The study is being conducted for rainwater harvesting and groundwater recharge. And for groundwater recharge, the recharge kits are constructed in various parts of the municipalities, and especially in those parts where groundwater extraction has been done, sir.
Okay. Right. Yeah. I don't know if there are other. Yeah.
Are there any more queries, sir?
I don't think we have questions from online, so I think we're going to move on to the next presentation. Thank you again for your presentation. Thank you very much.
Thank you, sir.
We would like to have now, if possible, the presentation from Mr. Acharya from TWSSM on small towns model water supply and sanitation sustainable delivery model in Nepal.
파일 띄워드려야 되나요? 누구 드리면 되죠, 발표?
네. 그 나라양 지금 접속이 안 되는 것 같아서. 물어보세요. 나라양 접속되어 있는지.
Is Mr. Narayan Acharya online right now? Is he connected to the meeting? Because we have a presentation from him scheduled.
네, 원래 HDMI로 하셨는데.
If he's not online, then we can have maybe the presentation from Mr. Bikram Dahal from TWSSM. on and yeah, this is going to be a registered file, the video file. So we are going to get the video started now.
네 번째. 천천히. Is there radical in the line? We have some problem of the playing of your video, so could you present from by yourself by online?
저기 소리도 없고 화면도 안 보이게 우리 해야 되지 않을까?
Radhika, can you hear me?
Yeah, so we are going to first we are going to have the second presentation of this session, which is the use of georeference decision support system in localization of sustainable development goal 6 from Mr. Rajit Oja from DWSSM. So we are going to have this presentation now.
So basically, the constitution of Nepal has told the central government the right it goes about the central data management, which would be used by the provincial government and local government also. Our situation has shrinked from 75 offices to the lead agency of WASH to 15 temporary offices. So the data collection needs to be done by the local governments itself. So based on that, the collection, update and use of the data will be done by the local level, whereas validation and use of the data will be done by provincial governments, and guidelines update and use also will be done by the state government. So based on that, what we tried to develop different applications for inventory data collections and try to make it as a management information system and also the decision support system for the local government as well. So these are the different areas where we are collecting the data, including the functionality of the water supply schemes to wash on public places and every management function related data of wash. So the process involved would be the data collection would be done by the applications, and then the raw data would be uploaded to the server, and then based on that server, the process and that server would give the process and structured data, which would act as which is the web-based GIS enabled MIS. It is spread across MIS. So there are two types of data now. One is what you call universal access, and the other one, the user need to have that ID to access other data. But in the future, we are thinking of making the data open access so that it could be linked with research and development as well. So based on that, dashboard has been prepared, as you can see here. This is for the functionality and sustainability of water supply services. So for the decision support system also, the dashboard is being prepared now. The data collected areas you can see in the yellow patches. As you can see, the scheme level data also can be accessed inside this MIS. For the wash plan, the water supply resource calculation has been done based on the ladder of services, and all of the services has been trying to make safety management and the investment requirement has been calculated inside the system. Similarly, for sanitation also, requirement for safety managed sanitation services has been calculated. The indicators are in line with the global indicators and also with the national planning commission indicators. So based on that, what we have tried is we have tried to identify the possible gaps inside the local government. The institutional capacity gap has been trying to use the required institutional capacity, and the gap has been tried to calculate. We have tried to calculate through this MIS, and then the investment calculation has been done here. And for information, this whole MIS serves the purpose for the information gap. Based on that, the guiding principle of wash plan has been prepared. Manual on how to use and wash to formulate the wash plan has been prepared. Process manual has been prepared. The estimations, calculations manual has been prepared, which gives the automated wash plan draft, which will make the local government job easier. This has been made based on the few guiding principles, such as leaving no one behind, that no one should be left behind in accessing the service. And the financing instruments should be such that it would make the whole wash facility accessible and affordable to everyone in terms of assessing operational cost as well. The monitoring of the service, the obtained data after monitoring should be submitted to the National MIS portal, which can be accessed by provincial government and federal government. The institutional setup of the local government should try to ensure the human resource element, doing everything, the planning purpose, human resource costs, such as technical assistance in training costs have been calculated. So they should be able to fulfill those human resources, try to establish the institutional setups. The resources for capacity development has also been calculated. So local government can develop their capacity based on the requirements suggested by MIS. This can be assisted by provincial and federal governments. Washing all situations should be sufficed. It is expected that local government would form its own contingency plan so that the service could be continued in all situations. Priority set up small level capital investment in medium term and bigger level capital investment in 8 years have been set, and the local government should be able to set the priority according to their needs. The overall costing has been done on life cycle cost approach, which provides useful frameworks to save methodology for providing better insight into this one in the future. The major funding, as you can see, the capital expenditure fund is only the tip of the iceberg for the wash. So all required operating expenditure need to be calculated to be the real wash plan. So all calculation has been done so that they could assess the required operational expenditure as well. So based on that, the capital expenditure has been calculated. The expenditure required to maintain those capital also has been calculated, and the operational expenditure also has been calculated, and the direct support also has been calculated. And monitoring, evaluation, and reporting will be done. The reporting system of wash plants will be capable to report in line with the national and international, mainly SDG 6.1 and 6.2 goals and commitments. The process will involve profiling through these 15 apps, and then the goal setting will be done by the system itself. The activity will be developed by the system itself. The prioritization of the project and gap option will be decided by the local government. They will put those data inside the system. The setting of the priority, short term, medium term, and long term will be done. And the options for the bridging the gap also will be given by the local government. So there are a few possible interventions to improve the functionality and sustainability of the project's post-wash plan as well. For example, when the water user committee uploads this data inside the system, then they will know where they are in terms of key performance indicators. They have certain milestones, and after reaching every milestone, the performance based grade can be given. So that will help them to improve their efficiency as well. And the milestones can be, for example, for the rural areas, the milestone can be minimum number of meetings that the board, what is the committee, the account staff is present or not, the standard operating procedure is prepared or not, business plan is prepared or not. If all the management criteria suffice, then the capital investment will be given to create a milestone for getting the minimum level of service. And the wash plan will include water supply, sanitation, washing distributes, and washing public places and washing healthcare facilities, where the recent reporting will be done based on the indicators and based on the criteria of international reporting arrangements and national private commissions. And the planning will be done to make all facilities safe to manage. This is the overall milestones and progress. For the water supply functionality and sustainability, similarly for service level benchmarking, also the work has started. The creation of institutional wash profile, the work has started. Decision support tool for local governments, also the work has started. Financial tracking and business module, the work has started. In business module, the private sector can assess where the markets are inside the wash. They can develop their business based on the market requirements. Sanitation service functionality and sustainability, and service level benchmarking and integrated performance benchmarking, including integrated standard and wastewater analysis. The work has started on doing those and building that in management information system as well. Preparation of capacity development master plan for asset owners and utilities as for the functionality and sustainability indicators has been prepared. And this has been done by different development partners. How the MIS will be used as the decision support system for wash utilities. Wash utilities can make their vision. That vision might be to cross 70 number in functionality or sustainability, or to satisfy the sustainable development goal criteria, or being initiated after satisfying the sustainable goal criteria. And also that can develop the indicator for MIS. According to the indicator of MIS, they can develop their the MIS can develop the business plan based on the rate of that area, and that business plan will give the utility idea about how much investment would be required in the upcoming 15 or 20 years. Similarly, for local governments, the wash plan development can be done here. Strategic reporting can be done, and identifying the investment options can be one of the possibilities. And also, it can help to develop the market from local perspective as well, because it will give the material requirements that can help the business development. Similarly, for federal and provincial governments, the STP revision and tracking can be done, STG monitoring can be done, and identifying the investment options and developing the result-based financing, developing guidelines can be done through this process. Thank you very much.
Yes, so this was the presentation from Mr. Rajit Oja, which was registered and we display now. So we've got just one presentation left, which is the presentation from Mr. Ambikram Dahal, about NRW assessment in the context of Nepal. We can see you are online, but I don't know if you can hear us or if you can share your screen with us and your presentation, please. It looks like you joined the session. We can see your name, but if you are able to speak or to share your screen, please. I think maybe your microphone is on mute at the moment. Maybe you could bring back the sound because we cannot hear from you. 채팅에서 아무것도 없어.
These are comments of my.
It's playing the video now, so we better use this.
Yeah, so we have the video of the presentation from Mr. Ram Bikram Dahal, so we will play the video of the presentation now.
These are comments of my presentation. Background is access to drinking water and sanitation is a basic category as per Constitution of Nepal. Implement of water supply and sanitation system and sustainable management of that system are the main priority program of government Nepal. And we issue water supply and its specifies to guide this priority and sustainable development of water and sanitation. Basically, there are two types of sources of water in Nepal: surface water and groundwater. And there are three types of water supply operators and according to operating in Nepal. Water use and sanitation committee or rural small towns.
PPT가 아닌가 보지.
And there are three types of water supply operators that are according to operating water use and sanitary committee for road in small towns. Local water supply corporation management, water supply management board for bigger town cities, and QQ carbon management. So simple scenario for drinking water supply at one institution, especially in the dry periods. We can see the different features where people are facing difficulty for getting one bucket of water. So if this address is not if this issue is not addressed, then the scenario will improve. So this leads in the future that there will be war for water. So how to get out of this? There may be many solutions, but one simple solution can also bring a lot of changes. We can provide lots of water to the one. The best options that we can do is control this type of flow. So we can control the flow, overflow, pipe breakdown, pipe leakages, and water tank. So if we can control only this kind of issues, then watershed from this can be solved to millions of people. And also we have to think that we are social media, we are doing lots of bucket challenge, but we can think that for that one bucket of water, in case of remote area, a boy or girl has to travel minimum 3 kilometers to get for water. So you can see the importance of this bucket of challenge also. So what's the target that the Department of Water Supply has kept in mind to meet all this scarcity limit or minimize the scarcity of water? So this is a statement that I have prepared from. Here, by 2024, there will be access of basic water supply to all the people of concern. Whereas, as per NPC plan, Nepal Planning Commission, for medium leakage of water, the government is targeted to get 60% population. So in the 60% population, what will be the target? They have is targeting to meet around 42% by 2030, whereas 24% by 24, and 8.69 is coincident that the deregulation is providing millions of water. Within this 24%, then 42%, medium level service water will be provided as shown in the pie chart diagram. Then LNG project that currently is running and both will be operated soon will cover 8.7% population. The power supply corporation will provide about 6.6%, and provincial projects will cover around 10.7% for excess of medium surface water. So the deregulation is target as shown in the diagram that they will meet the NPC plan. So this has been taken from the source of DW in this plan. So what NR? So this is just a pictorial view of NRW management. So NRW, what is NRW and what is non-remitting water, what is remitting water? So this is the basic concept that most of all of us know. So this is just a picture view. Remitting water is the on-bill meter, or the water losses during from the production to the consumption phase. So this segment is known as non-remitting. Those which water is not generated into monetary value is non-remitting water. So how is it calculated? As a simple mathematical rules. So in our MSP and percentage is A minus by A in 1 A is a system portfolio of water input distribution per annum, whereas the P is equal to total water source per. So who is responsible for reduction in NRW? So this is the picture view. The NRW management is the responsibility of all the stakeholders who is directly involved from this production phase to the consumption phase. So we can't say that I'm not responsible. So everybody is responsible for increasing the environment. So this is some statistic how we can control environmental management study. So there are currently many technologies are also used in aeroplane like DMS establishments, pressure management, leakage equipment, dequalifying monitoring system. So this is just picture view of determining the environmental water. So what are the technologies? As I just said, there have been technologies now using so-called environmental management, like smart water management, SCAR system, DMA with updated measuring for media or devices, more effective equipment to manage fluid and reduce system pressures like leakage equipment, and new instruments for engaging the private sector such as performance-based contracts. So this is a reference that I'm taking from one's presentation that globally NRO water is estimated to be present at $39 billion per year. So you can think how much money is can be saved from saved in conveying the end of the water. So now in context about what are the tools, what are the technologies used in the past. So I'm going to discuss some of it. But still, till date, there is no specific technique here. So NRW is calculated as I mentioned earlier, that include volume, time in hour from water to fill RVT, and total irrigation total water is calculated. Difference of total input and frequency is NRW. Now, small down projects from first, second, and third have installed in our flow meter to measure the quantity of flow and also for calculating the consumed quantity by the customers. But due to lack of training and methodology, most of the flow meters installed in this small down projects are broken and are not in use. Now, government projects are also trying to use some flow meter for their new projects like co-financing projects and climate resilience projects. The DMA concept has been designed for upcoming 22 orange horizontal projects and 10% project kind like ADB. So till date, SCADA system are installed at 2 water supply projects financed by ADB, but these are also not in operation due to lack of technical power as well as licensing issue. So I'm review of the SCADA system installed at 2 water supply projects. This one is from Kundopur, and this one is for Pindi. But unfortunately, these both systems are not running till now, and WC are frequently asking how we can operate and run this system. The department is trying to resolve these problems. So now, what's the role in environmental management of derivation system? So derivation established examinate for critical and institutional support for water supply users and committee, and suggests remedial measures for decommissioning including the water evaporators. So the team did what was the methodology that the team did for in the sustaining procedure. There is a field trips, there is for some benchmark data book like CIO, there is meeting interaction with the issue members, and there are also different formats as to get the data from to get the previous data in of their production and consumption details. Based on that, the team categorized 3 types of issues mainly are mainly faced by the water users committee. So they are defined in technical, discipline, governance, and financial. So in technical, most common problems for all water users committee is NRV reduction technology and equipment. So what we observe here, around 55% of water is leaked during the site visit in Ghana. Based on so on that findings, what did the department did? The department was a designated appropriate flow meter and an initiative for calculating the production distribution country water. They also decided to properly segment for mining leakage and pipeline and segregate 4 small towns as finding for air assessment and implement water process for finding from piping group. So this is a picture review. what is the scenario of that department's role. So they did an NRI assessment on basis of the soil screening and did the procurement on need of field monitoring. They developed one package for flow meter and literacy equipment. They did the tender and evaluation was also done, but there was no. They didn't find any company suitable as suitable liable for the procurement. So the tender was cancelled. And another private projects at Robozy department developed this all package code and they request for RFQ but this was implemented to COVID-19 and now this project is cancelled. So this is a scenario, but both of them are cancelled. So if NRW can manage, then what will be benefit to the water users committee? So whatever the utility can generate more additional revenue from this water, and more efficient system work with customer service. There was that customer service, and this is using supply hours and water all. You can see the scenario that this is one scenario. This whole scenario can be converted to this. We can manage not human beings. Also animals also need their water supply for their life. So water NRW and inspect, I don't know, water is that inspect team did. So I'm going to proceed that. Inspect team did a few more things for data collection for this benchmarking report on 11 KPIs of physical water debate. Then from this benchmarking report, also you can see that NRW ranges from 50 to 55% with an average of 26%. And NRW for Nepal water supply projects, 21 by from 12 to 65% with an average of 38%. And NRW typically as well. So this, we can see that what is the average percentage of water being lost. So from this water, it's meant that the estimate 14 million cubic water per year is lost due to NRW access due to these small projects. The revenue loss due to NRW per year is around 200 million, assuming that program cost is another 14 per million cube. And maintaining NRW 50% save for 6 million cubic water per annum, about 18 million revenue. And this project can serve 2 million people assuming LPG treated water without any water. So what are the main challenges faced by the water utilities in maintaining the NRW? Dilapidated infrastructure with high leakage levels, poor operation and maintenance policy, poor governance, immediate skills in non-revenue water management, financial constraints, weak neighboring environment improvement incentives, political culture and social intent, high commercial water costs, and illegal consumption. This is the main issues, challenges faced by the. So we were forwarded that I found is that we have to continue the cancer procurement, open end assessment, continue acquiring projects, and other best practices and one of the best main things that I have been expecting from this company is that the Nepal government, we have been searching for capacity so from this as well support in controlling and with public technology. Because I think for this seminar, I guess some of you may have interest to support our group. Thank you. And this is my presentation. And I'm very thankful for all of you.
Yeah, so this was the last presentation of today's session. So there were a few technical issues, so sorry about that. So it didn't really flow very easily, but yeah, we got all the presentations in this session. I think the content was very interesting. It allows to understand better basically what are the problems that Nepal is facing right now. And also you presented very interesting initiatives, like in the Tulikan municipality, you presented interesting initiatives about how we could go forward and try to improve the situation. So that would be importing technology from abroad and gaining some knowledge about how to use and install it in a type of capacity building type of logic, but it's also, as you mentioned, local initiatives to help people gain knowledge about the methods that they need to implement in order to improve the situation in terms of sustainable water supply in Nepal. So I hope the session helped everybody to get a little bit more insight on the situation and on what could be done for improvement. So anyway, thank you very much to everybody for joining today and for participating in this session. And we are coming at the end of this session now. We got the presentation. So yeah, thank you very much again. And I think we are going to close the session with this last presentation. Thank you.